So today we'll be doing an experiment on static equilibrium. So over here are the materials you're going to need. 2 spring scales, 1 weight, a roll of masking tape, a calculator, and a protractor. On the board is already a piece of masking tape. And so to start off our experiment, we hook these 2 spring scales to the board. Then we add on the weight. This line is right where this rubber band touches. So, or the vertice of the angle. So, we take 1 piece of masking tape and put it at this angle. And then we take another and put it at the second angle. So from there, we get theta 1 and theta 2. On this spring scale, there's newtons. So that would be force 1, and we measure that 1.75 newtons. For force 2, the newtons are on this side, 1.37 newtons. And now we're going to look for the 2 angles. We're going to measure those. So we take off the spring scales. And place the protractor right on the angle. Theta 1 equals 44.0 degrees. For theta 2, we do the same. Theta 2 equals 31.2 degrees. So we will be drawing a free body diagram to show the forces. The first force we're going to draw is the weight. This force is mg. Our mass is 200 grams. Second force, or more like this is our force 1, and this is force 2. So, from there, we can draw the components of the force. This force from here to here, and this force here should be the same. So this force and this force should add up to equal mg. So this top force is F1 sine theta 1. This bottom force, F2 sine theta 2. These forces, this one is F1 cosine theta 1, and this one is 2 cosine theta 2. Because the object that we hung here was in static equilibrium, the x components of F1 and F2 are equal, or should be equal, and the y components of F1 and F2 should add together to equal mg. Write our equations. mg equals F1, sine theta 1 plus F2 sine theta 2. So mg equals the mass, which is 0.2 kilograms, the original mass was in grams, times 9.8, and that equals 1.96. F1 sine theta 1 plus F2 sine theta 2, if you plug in the numbers, is 1.75 sine 44 plus 1.37 sine 31.2. That equals 1.93. Now, you can see there's a difference between these newtons, sorry. Did not label these two. So now you can see that there's a difference between these two numbers, and they should be the same, so we will calculate the percentage error. And percentage error would be absolute value of mg minus F1 sine theta 1 plus F2 sine theta 2 divided by mg. So that equals 1.96 minus 1.93 divided by 1.96. From there, you get 1.77% error.